Greetings, algebra students. Here's page 2. When we're looking at these systems, now they've asked us to solve it by substitution. So we have to look at our two equations and see how many, if any, are solved for a variable already. All right, now you can see that one of them is. This one's solved for y. All right, because of that, and because every system, the two equations have the same x, y values, so if y, it works for one of the equations, it's going to work for the other one. Because of that, I have y in two places here, and it says y equals x plus 5. So now I can write this equation, and in place of the y, I can put what it says y equals, which is x plus 5 right here. All right, now it becomes a rather easy problem to solve. I can combine like terms. 3x plus 5 equals 11. Subtract 5. 3x equals 6. Divide by 3. X equals 2. All right, now I use that information to figure out what y equals. I need both x and y. So I'll pick one of the two equations. I'm going to pick this one because it's already solved for y, so this will be a very easy one to use. So now I'm going to do y equals 2 plus 5. Y equals 7. All right. And now you can check it using the other equation, which you haven't used yet. 2x plus y equals 11. So I'll put in 2 for x, 7 for y, and I've got 4 plus 7, and that does equal 11, so I know that my answer is correct. The answer is the ordered pair 2, 7. All right, so that's substitution. Now, key to that was looking at what we had for equations prior to solving it, helping decide how I was going to solve it. So look to see if any of the equations are solved for the same variable. Because if you do that, sometimes you might be surprised to learn that, hey, look at this. Both equations are solved for the same variable. So you could solve these by graphing, or you can remember what President Lincoln said, that two things equal to the same thing are equal to each other. They're both equal to y. X and y are the same for this system of equations, so we're going to get the same x and y value for both of these. So therefore, I can put these two equations equal to each other. All right? So now the advantage of this is, see, I can't solve this very easily with, as long as I have two different variables in the equation. Now I've figured out a way that I can solve this and get only x's in the problem, or only y's. In this case, it's only x's. So here's what I'm going to do. I can't have x on both sides, so I'm going to take care of that piece. All right, and then we've got add 2. And finally, divide by 3, and x equals 3. So we found x. All right. Now I'm going to take one of the two equations, and I'm going to take the top one and substitute x in place of it. So I have y equals x minus 2, and I'm doing this so I could find what y equals. Very simple math here. 3 minus 2 is 1. Looks like y equals 1. All right. Got to be sure, though, so I'm going to check it in the other equation, this one here. So for the check, I'll do y equals negative 2 times x, which is 3, plus 7, and I'm thinking that y is 1, so I'm going to put 1 in place of place of it. All right, now let's do the math. Negative 2 times 3 is negative 6, plus 7. So 1 equals 1. It worked. I got the same thing on both sides. That means I have the correct answer. 3, 1. All right. Now, that's solving by substitution, where both the variables or both the equations are solved for the same variable. All right. Let's look at our next one. All right. It says problem 7-8. Solve using elimination. Show all work. So here we go. Elimination is usually most people's favorite way because it's clean, it's quick, and it works very well. Okay. What we're looking for is either in my x's or in the y's, I've got to have opposites. Now sometimes I'm lucky, like in this case, I already have y's set up as opposites, negative 6y and positive 6y. When that happens, we can add both equations together. So we add the x's together, we add the y's together, they'll cancel out because they're 0. Anytime I add opposites together, I get 0, and then I'll add the numbers. 5x plus 3x is 8x. Negative 32 plus 48 is 16. So we divide by 8, and x equals 2. Okay. Now, once we've got that first variable, we just pick one of our two equations to find the second variable with it. So I'm going to just take the top one, 5x minus 6y equals negative 32. In place of x, I'm going to put 2. And what do we have? We have 5 times 2 is 10. Minus 6y equals negative 32. And then we subtract 10. We've got negative 6y equals negative 42. Negative 32 plus negative 10 is negative 42. And then finally we're going to divide both sides by negative 6. And y equals 7. And on the last, we'll check this using the other equation. So that's 3 times x, which is 2, plus 6 times 7. And we're seeing if that equals 48. 3 times 2 is 6. 6 times 7 is 42. And it does equal 48. So we know we have our correct answer, which is 2, 7. Elimination. Nice way to solve a problem here. And again, the whole thing is we're trying to get an equation where we only have one variable and not two. And this is what this helps us do that. All right. You can see we do not have opposites. We have opposite signs in the x's, but we don't have exact opposites. And we don't have opposites in the 11 y's here, but they almost are opposite. All right, so what do we have to do? We have to multiply one of these equations by negative 1. That will turn one of those 11 y's opposite. And you can do that as long as you multiply the entire equation. So I have negative 5x, or now it's positive 5x, I should say. Okay, and negative 1 times 11y is negative 11y, so minus 11y. Negative 1 times 59 is negative 59. Now I take my equation that I did not change, and I can put it below. So here we have 8x plus 11y equals 20. All right, now I've got opposites, and I can add the two equations together. I can use elimination. 5x plus 8x is 13x. The y's will cancel out. Negative 59 plus 20 is negative 39. And then dividing by 13 gives x equals negative 3. Alright, once we've done that, now it's a very simple matter to go in and do our next step, which is to find the second variable. I'll just take the top equation again, 8x plus 11y, and when I go back to find the variable and to do checks, I must use the original equations that I had. Can't use equations that I've altered. So the original ones they gave me. So here we have 8 times negative 3 plus 11y. Does that equal 20? 8 times negative 3 is negative 24 plus 11y equals 20. Alright, next step. I'm going to add 24 to both sides. There, that cancels out. 11y equals 44. And as you can see, now, dividing by 11, we get that y equals 4. Alright, and if it works in the second equation, then I'll have my check. So here it is. I got negative 5 times negative 3 plus 11 times 4. See if that equals 59. Here's 15 plus 44 equals 59. And it does. 59 on both sides. So we're good. Alright, that's it for this page. We'll see you on the next one.